Okay, Chapter 7, Lesson 2. Yesterday we worked on extended facts, taking things like 3 times 6 is 18. So then 3 times 60, making 6 10 times greater, would be 180. Talking about the shift in the place value and moving things over when you multiply by a power of 10, moving it to the left once by a power of 100, moving it to the left twice, and by 1,000, moving it to the left 3 times. And then we even increase that by what would happen if you multiplied by 10,000, that would be 4 times, and 100,000, that would be 5 times. So just really understanding that movement with numbers when we multiplied. We're going to take what we learned yesterday and move this into a multiplication algorithm, which is solving a multiplication problem or situation by putting the two factors into an area model and then breaking it up by place value and looking at partial products. So what we talk about when we have area is in a rectangle. We said the area of a rectangle equals the base times the width, okay, or length times width, or, I think we even said base times height, which also means the same as saying the area equals length times width. So sometimes you see it B times H or L times W, just so that you understand that we have the base here and the height here, or the length and the width, multiplying adjacent sides to figure out the area. So taking into consideration, we have the rectangular sections or the area model for multiplication. Very similar to what you learned in 3rd grade with everyday mathematics when we talked about partial products. But it's nice to put it in this area model to get an understanding of what's happening. When we say partial products, what we mean by partial products is looking at the place value and multiplying by place value. So when we do the shortcut method, we kind of do all those things in our head. And I know course 1 you've been working on the shortcut method, but really not really understanding connecting your product and what's happening in the shortcut method. That's why we're backing up just a little bit. So we have the problem 43 times 67, and we're going to put that into an area model. So we make a rectangle and say this is 43 centimeters times 67 centimeters. Remember, in an area model, we want to know how many squares are inside. So here is our big rectangle. So up here we have 67 by 43. So we've taken that and we've broken it apart by place value. So we've looked at the tens and the ones. So we said in 43, there are 40 tens, so 40. Right here I have 40, and there are 3 ones, so 3, because 4 plus 3 equals 43. Sectioning off our 3 into the smaller rectangle, and then we are sectioning off our 40 into the larger piece. And then on our side that measures 67, we're breaking it apart by how many tens and how many ones? Well, we have 6 tens, so 60, and 7 ones. So you'd be picturing it like 7 cubes here, and then we have 6 longs on the top. So looking at place value, once we've done that, then now what we can do is we can take piece by piece and do the multiplication. So in our 40 by 60, we're going to multiply 40 by 60. So 4 times 6, remember, we can say is 24. But 4 is 10 times bigger and the 6 is 10 times bigger. So that makes our product 100 times bigger. I hate to go back to this, but for some of you that are still struggling with understanding what's happening, to give you that confidence, remember, and we'll just keep pushing that place value understanding. You have 4 times 6, which is the 24, and then 2 zeros, which you have 2 zeros in your product. Counting over 1, 2, 3, 2,400. Once we multiply that, then we take now 40 and multiply it by 7. 40 times 7, we have 4 times 8 is 28. It's 10 times bigger, so 280. Come down here, we have 3. Now we're going to multiply 3 times 60. 3 times 6 is 18, but 6 is 60, so it's 10 times bigger, so our product is 10 times bigger. And then we have, last but not least, 3 times 7 is 21. When we get all of those products, then what we're going to do is take them and add them all up to see what our final product is. So we have 2,400 plus 280 plus 180 plus 21. Okay. Add those all up. 1, we have 8 and 8, 16, plus 2 more 10s is 18 tens. Carry the 100. 100 plus 400 is 500, plus 200 is 700, plus another 100 is 800. And then we have 2,000s. So we have 2,881. We've broken it apart by place value in that area model and combined all of our products to get a final product in the end. Using multiplication or estimation to check our reasonableness, is this about right? We can go back to our original multiplication problem, 43 times 67. 43 is closer to 40. 67 rounds to 70. Multiply those out. 4 times 2, or 4 times 7 is 28. And it's 100 times bigger because I have 2 zeros. That means 2 place values I'm moving. So 2,800. So checking my estimate, 2,800, with my final product, 2,881. It's a good thing to do. All right, so here we have one that's not done for us, so let's do it together using the area model or rectangle sections to solve the multiplication problem below. 39 times 54. Really, when you're drawing the picture, it doesn't matter which way you put it. You know, if you put the 34 on the left and the 54 on top, or vice versa, it's just that you have that area model for you. So 39 breaks apart, and we have 30. So 3 tens, 30, plus 9 ones, and 54 then is 50 tens, plus 4 ones. Okay, piecing it together, we're going to take 30 times 50. Well, 3 times 5 is 15, and it's 100 times bigger, so 1,500. Moving over, we have 30 times 4. I know 3 times 4 is 12. 110 bigger, 120. Continue on, filling up all these spots. I have 50 times 9. 5 times 9 is 45. It's 10 times bigger. And last but not least, 9 times 4 is 36. Making sure now that I take all 4 of those products, and especially with addition, that I'm lining up my place value so that I add correctly. I have 6, 2 and 3 is 5, plus 5 is 10 tens, so I have 100 and 0 tens left. 1 and 5 is 6, 6 and 4 is 10 hundreds, plus another one is 11 hundreds. So I have 100 and 1,000. 1 and 1 is 2. Don't need to be meaning to confuse you guys, but always focusing on that we understand our place value. So we have ones, tens, hundreds, thousands. We have then a final product of 2,106. Is that about right? So let's take and do an estimate. 39 times 54. 39 is closer to 40. If you're not remembering that, remember we look to the digit to the right. 5 or more, it's going to tell us to soar. 4 or less, it's going to tell us to rest. Well, 9 is 5 or more, so it's going to soar to 40. Over here, we have the 4 is going to tell us what to do. 4 or less, let 5 rest. It's going to stay 5, and we'll multiply. 5 times 4 is 20, but it's not just 20, it's 100 times bigger. So it's 2,000. 2,000, is that close to 2,106? Yes, it is. So I know that with as much possible or confidence as can be that I am close in my multiplication. All right, so that was area model, and tomorrow you're going to spend a lot of time practicing with area model. But with area model, we have something that's very similar, but you don't use the rectangle. And I know some of you remember this from last year because this was your comfort where you like to do multiplication. And so we are going to solve with expanded notation. Let's look at the two diagrams that show what expanded notation is. It's taking what in our head, what we just did with the rectangle section, and not drawing it out in picture form, but just doing it with numbers. So just a little bit, I don't know, not as hands-on, for lack of a better word. So in expanded notation, you're in your head visualizing the place values and knowing how much those digits are worth, and then putting that into your algorithm. So if we take 43 times 67, we know that 43 is 40 plus 3, and that 67 is 60 plus 7. We can write it out, or like in problem B, we're just using in our head or thinking in our head that we know about the place value. And so we're going to expand below the different products instead of building in the rectangle and then taking all those products and adding them up. So when we look at our multiplication here, let's see if I can make this bigger. I don't think it's going to let me zoom in just a little bit, guys. Here we go. Oh, zoomed out. Let's zoom in a little bit. Okay. When we're looking at this multiplication, then we're going to start with our multiplying. We're going to multiply 40 times 60. That's going to give us our 2,400. And then we're going to take 40 times 7, which is 280. And then we take our 3 times 60, making that bow tie up above, 18 or 180. And then last but not least, 7 times 3 is 21. Remember that with multiplication, when we have that commutative property, you know, b times a is the same as saying a times b. You're going to get the same product. So it doesn't matter which way you go, because sometimes we prefer to start out with the ones digit and then go to the larger place value. We should end up with the same product in the end. So once you then would get all of those, then you're going to add them up and have your final product. So let's get away from this page and just do a couple together. So let's say I have, let's do 58. I'm going to move it over to the center here. 58, and I'm going to multiply 58 by 25. In my head, I'm always doing estimation to make sure. So 58 is about 60, and 25 is about 30, rounding it to the nearest 10. 3 times 6 is 18, and it's 100 times bigger. So 1,800 is about where I should come out with. All right, to do the rectangle section with this problem, I'm going to make a rectangle, not the prettiest looking thing. Okay, so I'm going to make a rectangle, and then I'm going to break the rectangle up into its place value. Okay, so up here I'm going to have 50 plus 8, and then down below I'll have 20 plus 5. Okay. And then now I can start looking at it piece by piece. I have 20 times 50. Well, 2 times 5 is 10, and it's 100 times bigger. So that's 2 digits over. Shifting, and then I have 20 times 8. Well, 2 times 8 is 16. It's 10 times bigger, so 160. In here I have, remember, they just come down and you line them up kind of like a multiplication chart. So 50 times 5. 5 times 5 is 25. It's 10 times bigger. And in the last box I have 8 times 5 is 40. All right. Finally, I do that all in my rectangle, and to break them apart and add up all my products. Lining them up, that is the most important thing with that multiplication. And even when we get to the shortcut method, I know that some of you in course 1, that was one thing that you were having difficulty with, you do all the multiplication correct, but then when you had to come down and or add all of those products together, it got tricky. So 0, we have 5 and 6 is 11 tenths plus 4 tenths is 15 tenths. So that's 5, carry the 1. 1 and 2 is 3, plus 1 is 4, and 1 comes down. 1,450. Checking with my estimate. You know, they're relatively close. So I would feel confident in my multiplication. Now, if you didn't want to do the rectangle method or the area method, so here's the area method of multiplication, you could just simply do with the work that we did up top by doing the expanded notation of multiplication. Expanded notation is also the same as partial products that you started to learn in 3rd grade. So we take our original 58 times 25, and we're just going to picture in our head, you know, we can picture that area model or thinking of the place value. That 58 is 50 plus 8, and that 25 is 20 plus 5. You certainly can write it out like in example A, or you can just know this in your head when you're multiplying. You can start with the tens in this form of multiplication, but just because I like to get used to when we get to the shortcut method, I like to do it starting with the ones. So I have 5 ones times 8 ones is 40. I have 5 times, not 5, but 5 times 50. Okay, and 5 times 50 is 250. That's why at this point right here, doing expanded notation, it's kind of nice to say and put on the side, just like in example A, what your multiplication is. Okay. We've multiplied by 5. Now we're going to start with, it's not 2, it's in the tens place, so it's 20. So we have 20 times 8 is 160. And then we have 20 times 50, which is 1,000. Taking all those products, like I said before, you can be writing on the side here so that you remember the place value. So one thing that's tricky about this notation is you have to remember that it's not just 5, that it's 5 tens. But then when you're all done, then you're going to add it up, making sure everything's lined up. 6 and 4, 10 plus 5 is 15 tens, which is 5 left. Carry the 100. 1 plus 2 is 3, plus 1 is 4. And bring down the 1 in the thousands place. So even simply doing this and expanded is that I understand that you understand place value. It's always okay to do the work on the side to make sure you're getting it. And then we'll also work with that rectangular section and area model of multiplication. Thank you for watching the video. We'll see you tomorrow, and have a good night.